in the time it will take to set up and fill tankers in a water shuttle using small portable pumps. This structure could be lost. A method now being deployed nationwide in rural areas, called the dry fire hydrant system, is helping to solve this problem of delivering large volumes of water to the fire ground.
For years, rural fire departments have had to contend with poor water access, time-consuming portable pump setup, low-volume water flow, ice buildup, and plug suction screens. Most of these problems can now be solved by planning and installing a dry fire hydrant system.
Like a city hydrant system, dry fire hydrants can be critically located in rural areas and easily constructed at a nominal cost. These hydrants should meet the standards established in NFPA 1231. Establishing a dry fire hydrant system can be compared to the familiar fire triangle. The three essential steps of a rural dry fire hydrant system are planning, permitting, and placement. The first step is to plan the dry fire hydrant system.
To develop a system of dry fire hydrants, all agencies or individuals involved should coordinate their efforts.
During the initial planning meetings, the decisions on location and priority for placement of the hydrants will be dependent on various factors: current and future population trends, property values, potential for losses, fire history of the area, potential water sources, Insurance Service Office Rating Bureau decisions affecting local insurance rates, and other factors of local concern. Remember, there is always the possibility of building an artificial water storage area and putting in a hydrant if there's a high-value area that is not located close to a natural water source. The finished plan should contain a map of existing hydrant locations and the siting priority for placing future dry fire hydrants. The circles around the hydrant locations show driving distances from the hydrant. Drawing these circles at varying radiuses will show how close together the hydrants will have to be placed to meet the standard for turnaround time established by the local fire service. Once the locations for siting the hydrants are determined, the next step is to do on-site inspections. This will show if the planned site will prove suitable to place a hydrant. Whether located on public or private lands, permission from the landowner for placement of the hydrant must be received in writing. The landowner should understand that an excavation for the hydrant will be made and that a permanent fixture will remain on the property. The next criterion is to check water depths at the site. Extreme fluctuations in water levels should be considered. Composition of the bottom strata must be checked. Muck and vegetation could cause potential problems with the suction screen. Make sure the machinery that will be used to place the hydrant can operate safely at the site. Consideration must be given to protecting the hydrant, marking the site, keeping the site free from grass, brush, and snow, and providing suction hose support. One item to avoid is high static lift situations. 8 to 10 feet of static lift is the maximum recommended lift. Before leaving, note the location of possible utilities, both overhead and buried. Some states require prior notification of utilities before digging can start. If all the inspection criteria are satisfactory, measurements for the length of pipe needed and the height of the static lift should be taken. Measure from the screen location in the water to the riser location on shore, and from the bottom of the riser location to the hydrant head to get the total length of pipe needed. Measure from the lowest water level to the top of the hydrant head to obtain maximum static lift. These measurements are approximate, but they should be as close as can be obtained. They will be used later in the design worksheet.
The next step in the planning process is to design the dry fire hydrant to fit the chosen site. A booklet on designing and installing dry fire hydrants is available from the Wisconsin Department of Natural Resources.
The last step in the planning process is obtaining cost estimates. Installation and parts should run from $700 to $900, depending on prices for machinery and supplies in your area. Cost sharing with federal, state, and local governments and organizations may be available to cover all or part of the cost. Donated time and materials may help to further reduce costs. These figures are based on using all 6-inch Schedule 40 PVC for the installation. The second side in the hydrant triangle is the permitting process. Before starting any construction, certain permits may be needed from federal, state, county, or local authorities.
To protect public interest, the state of Wisconsin requires that a permit be obtained prior to constructing any dry hydrant in any navigable water. The Department of Natural Resources should be contacted to determine if permits are required.
The joint state-federal application for water regulatory permits and approvals is the standard application form required for dry fire hydrant projects. The riparian landowner and sponsor, such as the fire department or municipality, must be listed on the form and must sign as co-applicants. A project plan is necessary to show permitting agencies the materials that will be used, the legal description, sponsors and owner's name, and general dimensions of the project. A plat map of the township or area where the hydrant site is located will allow the permit inspector to find the site. A lake survey map will show the affected area of the lake and shoreline, the water depths, and bottom vegetation in the area of the hydrant site. Land use agreements show that there exists a legal document between the landowner and sponsor, allowing the sponsor's use of the property. These agreements are recommended between the sponsor and each ownership that the hydrant crosses. These agreements may be registered with the Register of Deeds office and then would show on subsequent landowners' abstracts that a registered agreement exists for the hydrant. For those properties owned by governmental agencies such as boat landings and road right-of-ways, the attorney for these governing bodies may recommend that the governing boards pass a resolution allowing the sponsors to use these properties. After a complete permit application is received, those agencies which will issue permits will evaluate the project for potential environmental and recreational concerns and other impacts to public interests. During the review period, the state of Wisconsin requires a public notice to be published in the local newspaper, giving local residents and others a chance to voice their opinion at a public hearing if one should be requested.
If no comments have been received and no adverse impacts anticipated, the permit may be conditionally issued. These conditions are included to ensure proper erosion control and protect the public right of navigation. Only after permitting agencies have issued the appropriate permits can actual construction begin.
With the planning completed and all permits obtained, we can now go on to the third side of the hydrant triangle, the placement process.
For a smoother installation, all materials and tools should be on site before construction begins.
A contractor with a backhoe large enough to do the job is required for excavating the trench. Try to start the installation when the water is warm and at its lowest level. Start digging the trench, maintaining the correct depth all the way to where the riser will be located. It is less complicated to keep a level trench cut from beginning to end than to try to slope the pipe up from the shore. Sloping can be done if there is a need to conserve pipe and/or there are extreme elevation differences from the shore to the hydrant head location. While the backhoe is digging the trench, a crew can start assembling the hydrant.
We'll clean that up.
Instead of using a straight 90-degree elbow at the riser, it is better to construct a wide sweep elbow using two 45-degree elbows and a short length of straight pipe. If something should happen to the hydrant head and it was damaged or broken off, a 2.5-inch suction hose could be inserted into the 6-inch pipe, thus allowing drafting capability, although at a much reduced volume. When the trench is completed, take the final measurements to determine the correct lateral run length and the correct riser height. Cut off the pipe to these dimensions, then remove the rough edges, clean and prime, and finish gluing the pipe parts together.
Go in there.
When the glue has set up, using either a boat or people with chest waders, line up the screen and pipe along the edge of the trench with the people in the water supporting the screen. Make a final inspection of all pipe joints. If a faulty joint is found, it can easily be replaced. Cut out the faulty joint and deburr the ends. Prime the parts, glue and replace the fitting, being careful to keep the assembly properly aligned. Allow the new joint to set up before continuing with the installation. At this point, you should have the whole hydrant pipe assembly in the correct position, ready to set it into the trench. Making sure that the screen is correctly placed and the screen and pipe are directly over the trench. Sink the screen, allowing water to enter the pipe, and sink the whole assembly into the trench.
It is imperative that at no time should anyone be allowed to go into the trench. This creates an extreme safety hazard should the walls of the trench collapse.
If a mistake has been made and the screen and pipe miss the trench, or there are other problems, the whole hydrant assembly can be pulled back out by pulling up on the riser and bringing the whole assembly back out of the water. After determining that the screen is in the proper position, the trench can be closed. Starting at the riser and making sure that the riser remains vertical, start backfilling the trench. Mounding the dirt slightly over the pipe will assure a return to natural grade when the dirt settles, and will help prevent frost from reaching the water line in the hydrant. Consider covering the opening in the riser to prevent rocks and gravel from falling into the pipe during the backfilling operation. When backfilling is complete, the riser sticking up out of the ground must be cut off to the proper height. Make sure that after cutting off the riser pipe, the hydrant head will be below the pump intake. A pad should be constructed where the pumping unit will sit during drafting. Install guards to protect the hydrant and any suction hose supports that may be required. It is important to remember that there will be a lot of weight hanging on the hydrant head when drafting with 4 to 6 inch suction hose. Some type of support is a must. The hydrant should be test pumped to make sure it is working properly. This would also be a good time to determine flow rates for any insurance rating bureau record keeping that may be necessary. The hydrant should also be backflushed periodically to remove any buildup on the screen. There may be a need for some top dressing to be hauled to the site to finish leveling the area. Once this is spread and leveled, the disturbed areas must be seeded down and mulched to prevent erosion. To prevent freeze-up in cases where the water level in the hydrant is above the frost line, a system devised by the Wascott Volunteer Fire Department injects low-pressure air into the hydrant system to displace the water in the hydrant. This is accomplished by tapping the head or cap and installing an air chuck and pressure gauge. Because exposed PVC pipe can deteriorate in sunlight, it is imperative that it be painted as soon as possible after placement. Once the hydrants are all in place, any follow-up action that needs to be done should be taken care of. This could include notifications of permitting agencies to do final inspections of the sites, compiling of all bills, canceled checks, and records for submission for payments from grants, contacts with those municipalities or individuals that will be maintaining the hydrant sites. Maps for mutual aid agencies and dispatch centers should be made up and distributed. A fire plate or rural address may be given to each hydrant site to aid dispatch in directing vehicles to the water point. The Fire Rating Bureau and local insurance agencies should be contacted to see if the dry fire hydrant system could cause a reduction in ISO ratings and/or insurance premiums.
Although there are many factors that impact on a total water delivery system, such as available tankers, mutual aid agreement, road systems, available water sources, and dispatch capabilities, the ability to reduce the two factors of driving distance and refill time offer the greatest opportunity of reducing fire losses on the fire ground.
It should be noted that in those areas which have few natural water sources for hydrant locations, the construction of man-made impoundments may be considered. Construction of man-made water sources may increase the costs associated with a rural dry hydrant system. The extra investment will be paid back in potential values saved, possible reduced insurance rates, and increased safety of both emergency responders and the general public.
With some planning and a small investment of time and money, many rural fire departments can enjoy the same benefits as those departments with access to a municipal water system.
To receive a copy of the booklet entitled A Guide to Planning and Installing Dry Fire Hydrants, write the Wisconsin Department of Natural Resources, W 8945 U.S. Highway 8, Ladysmith, Wisconsin 54848 9567, or call area 715 532 3911.